So welcome you all. In today's lecture, we are basically going to deal with one of the most complex topic related to the unit 1 of digital electronics that comes under the subject of KOE 039. So basically we are going to deal with the K-map. We are going to first lay down the foundations about why we are using K-map, what is the advantage of K-map with respect to the Boolean algebra. Apart from that, we are going to deal with why in K-map we are using the gray code only, and why we are not talking about the binary codes. So we are going to see the difference between them, why we are using gray code. Then step by step we are going to deal with the 2 variable K-map, 3 variable K-map, 4, and we will move on till 5 variable K-maps. So let's start with the K-map. It's a brief introduction about the K-map. So in this, first of all we will see why we are using K-map. The basic need of using a K-map is that sometimes suppose that we are solving Boolean expressions or Boolean functions, complex Boolean functions, and it has been asked to simplify or to get the reduced form of a Boolean expression. Then what we do, we basically apply different kinds of Boolean rules, and as per that we get the reduced form of the Boolean expressions. But there is a possibility that we think that whatever the expression that we got is the reduced form of that complex expressions, but there might be a possibility that we might have missed some Boolean steps or some steps that would further reduce the complex Boolean expressions and further simplify that Boolean expression. So in order to remove that flaws, we are using another method of solving Boolean expressions, that is K-map. This is basically a pictorial representation of in the form of a map. So it's a very human tendency that whatever we are seeing in the form of pictures, that strike our mind, and we are concentrating on that thing, on that particular picture, more as comparison to some textual, some in the form of some text or words. So that is why K-map is also very useful to get the reduced form of a Boolean expressions. To get a foolproof method that will 100% there is a surety that if you have formed all the possible grouping in that K-map, then we will definitely get the reduced form of that Boolean expressions. Now suppose that in the K-map we are having an SOP, and we know that we are having 2 form of Boolean expression, SOP and POS, that is sum of product and product of sum. If we are having 2 variables, suppose that I am considering that variables as A and B, then that will be written in the form of this way. And in Boolean, in K-map, what is that thing is that we have to draw the cells, and that must be representing some min terms of a Boolean functions. So if we are having 2 variable in our system, in our Boolean function, then we will have to draw the 2 to the power of 4. That means 4 cells will be present in the K-map. Similarly, if we are talking about the 3 variables, it will be 2 to the power of 3. That means 8 cells will be present. Similarly, if we are having 5 variables, we will be having 2 to the power of 3. That is 32 cells in our K-map. So as we are talking about the 2 variables, so definitely we will be having 4 cells in our K-map. So in this, each cell is representing the value of a variables. So if you are talking about this cell, what is the decimal equivalent value of this cell? So it is, we are talking about first row and first column. First row and first column is covering 0 and 0, so it will become as, the decimal equivalent value will become as 0 and written as A bar and B bar. Similarly, this row, first row second column will be written as A bar B, decimal value will be 1, and this one it is A B bar, whose decimal value will be 2, and the final one will be AB, whose decimal value will be 3. So in this way we have filled the cells of a K-map. If you are talking about the sum of product form, On the other side, we are having a product of sum. So how we are going to fill the cells of a K map in the product of sum is just the opposite of the SOP. So in SOP what we are considering, normal variable in SOP, normal variable is represented by 1 and complemented variable is represented by 0. Complemented variable means it is having a value of 0. Similarly, this is we are talking about the SOP. Similarly, if you are talking about the POS, the normal variable give us a value 0. Normal variable give us a value 0, whereas complemented value give us a value as 1. This is for a product of sum form. Now let's fill the value. We know that this is 0, this is 1, this is also 0, this is also 1. So in this case 0 was represented by A complement, 1 by A. So this way B is B complement and this is B. Now in the case of product of sum, if we are talking about the 0, 0 is representing what? 0 is representing a normal variable. So that means this is A and this is A bar. Similarly, this is B and this is B bar. Now let's fill the each and every cell of a K map. So in this case, what we have to do, here it is first row, first column. So its value will be written as A bar plus of B bar, because it is a sum, product of sum. So each cell will be having a sum of variables. On the other side in SOP, each cells will be having a products of a variable, because it is a sum of product. On this side it is product of sum. So on this side, on the other hand, the value will be written as 0. This is 1, this is 2 and this is 3. So how it will be written as? It will be written as A plus of B bar, this one A bar plus of B, and this one A bar plus of B bar. So in this way we will try to write the value of a K map in terms of SOP as well as in terms of a POS form. Now the next thing is that how we are going to discriminate between the 2 variable K maps and 3 variable K map, because till now whatever the coding that we are using inside the cell is in the binary form, but we know that in the K map uses a representation which is called as a gray code representation. So whatever the cell value that will be having, it will be represented in the form of gray code. So what is the number of variables that easily discriminate between a binary and the gray code is the whenever you are having a more than one variable on row side, or whenever you are having more than one variable on the column side. So that picture comes into existence if you are talking about the 3 variables or more than 2 variables, then that picture come into existence about the gray code. Now the next thing is that why we are using gray code in comparison to the binary code. Why not binary code are used in the cell formation? So let us see why we are using binary code, why we are using gray code, and why not binary. So we will talk about 2 bits. So 2 bits will be having a range of 4 combinations. So let us try to first write that combination. So on the one side we are using binary, on the other side we are using gray code. Now before writing the binary and the gray code, let us first see how we can convert a binary into gray code. I will take a small example. Like suppose that I am having a binary number 10110. This is my binary number that has been provided to me, and I want to convert it into a gray code. Then what are the steps that I have to follow? Let me first write it as a B0, B1, B2, because this is a binary. So we are just generalizing the each bit. Now I have to get the gray code of this binary. So its corresponding gray code will be G2, G1 and G0. Now in order to write the gray code, the first step is that whatever the MSB of a binary code copy that MSB as it is in the case of a gray code. So in order to get the MSB of a gray code, I will copy the MSB of the binary as it is. So it will be written as 1. Now the next thing is that after this, the thing we have to take is just take the XOR of the consecutive binaries. So if I want to get the result for the gray code G3, I will take the XOR of B4 and B3. So it is 1 and 0 will be written as gray code will be, its equivalent will be 1 1, because we know that XOR is called as the inequivalency detector. So it will produce an output 1 only when both the inputs are unequal. So here both the inputs are unequal, so we will get an output 1. Now in order to get the G2, we have to again take the XOR of B3 and B2. So the result is 0 XOR with 1, again 1. Now for the G1, it will be B2 XOR with B1, and the result is 2 equal will be 0. Similarly, B1 and B0 will give me a value of 1 because both are unequal. So in this way, we will get the gray code of a binary code provided to us. Now next thing is that we want to write the gray code of this binary equivalent values. We have considered 2 variables, so 2 variables give 4 combinations. Now in order to write the gray code, let's try to write the gray code of this binary. It will be 0 0, then this one will be 0 1, then the thing is 1 1, and finally 1 0. So this is the gray code equivalent of the binary that is provided to us. Now the next thing is that let us visualize why we are using gray code. Now we will see the consecutive bits one by one. If we are comparing these combinations, let us see these two comparison is differing by how much bits. So if I am comparing the first and the second, how much bit is difference between these two combination? It is differing by 1. So this one is differing by 1, this is also differing by 1, this one is also differing by 1. So next, if we are comparing the first and the last one, you can easily visualize that there is a 2-bit change in the comparison. So whenever there is a 2-bit change, it is not possible to further reduce that expression, right? So if we want to get the simplified result from the K-map, so we have to use some kind of a coding, some kind of filling a cell in such a way that two adjacent cells are differing by only 1 bit. So if 2 adjacent cells are differing by 1 bit, then only in that case we could get a reduced form of a Boolean expression. Otherwise, if we are using binary code in the filling of a cell, so there might be some two adjacent cells. If we are filling that adjacent cells, we won't get a reduced form of from that combinations. So in order to get the reduced form from a combinations, instead of using a binary, you have to use gray code. Now let's see about the gray code, whether they are differing by 2 bits or only 1 bit. So the same thing we are going to consider here also, the comparison. Now in this case, if you observe it very carefully, you can visualize this. Whatever the combinations or whatever the comparison that you are making, in each comparison you will see only 1 bit change. So whenever there is a 1 bit change, you will get a reduced form of a Boolean expressions. So that's why this gray code is also called as a unit distance code. Unit distance code, right? So in this case, we get the reduced form of the expressions. Now the next thing is that once we got this information that why we are using a gray code, why not binary, because in a gray code there is a possibility to get the reduced form of a Boolean expression. Now the next thing is that to just utilize this concept in drawing the 3 variable K-map, 4 variable K-map and 5 variable K-map. Now we will see an example of 3 variable K-map. Suppose that we are having a function which is given as f equals to summation of minterms, which is 0, 1, 2, 4, 6. So these are minterm combinations that we got, and the question is to get the to find the simplified Boolean expression of the minterms that is provided to us. Now, in order to solve this, we have to first draw the K-map, and as this is a 3 variable K-map, how we can get this conclusion that this is a 3 variable? Because the maximum value that we are having is 6. So in order to get this value of a 6 in binary form, what are the number of variables that will be required? Is 3. So it is a 3 variable K-map. 3 variable K-map going to give me a combinations of 8 cells. So we will be having a 2 row and 4 column. So on this side I am writing A, B, C, 0, 1. Now the next thing is that in order to write the binary, or in order to write the gray code representation of each cell, we have to very carefully write the values. First write the values for column 1, then column 2, and in order to fill the next value, remember that instead of filling the second last column first, you have to fill the last column first. After that, fill the second last column. So we are having here second last column. In order to fill this column, we have to first fill the column last one. So if we have to fill the, write the value, it is 1, 0, and then finally fill the value 1, 1. In the similar way, you have to write the decimal equivalent value of each cell. So we will fill first one, second one. Instead of filling second last, first fill the last 2, 3. Similarly, 4, 5, 6, 7. So this is the decimal equivalent value of the K of the each and every cells. Now in order to get the reduced form of a Boolean expression, we have to write the minterms. So it is 0, 1, 2, 4 and 6. Now from this we have to draw the write the combinations. So we know that in order to fill the combination, first of all we have to observe which combinations of adjacent cells is giving me the maximized combinations. Like we are having a octet, we are having a quad. Similarly, we are having a individuals, we are having a pair, as well as we are having a individual minterms. So the combinations are octet, then quad, then pair, and finally individual terms. So always move from top to bottom. Search for the combination which is giving me an octet. If not, then find for the combination give me quad. If not, then pair, and finally individuals. So we will observe the things and we can easily conclude that there is a quad inside this combinations. We can form a quad like this one, similarly this one, and finally the thing that is left with us is the minterms 1. So we have to fill it, combine that value with this one, right? So in this way, remember that you can form a combination between adjacent cells, but you cannot form a combination between the cells which is diagonal to each other. Like suppose that I am having a value filled in this point, at this point, like if it is 1 and 1 here. So I cannot form a combination like diagonal thing. Diagonal is totally prohibited. We cannot use diagonal combinations. We can only use the combinations like in the form of rows, and we cannot move in a diagonal way. So its representations, its simplified form will be written as from these 4 combinations, or these combinations of 4 minterms. Whatever the things that we can take common here is, if we are talking about the rows, there is nothing that we can take common from the rows. So we have to just observe the from the column what we can take what thing that we can take common. So it is, we can take common in the column is C bar, because C bar is common in the first and the last one. So its simplified expression will be C bar. Now after this, what about this combination? It is giving me a combinations, or common term is this row. So there will be a bar. Now what about column, first and second? The thing that is common is B bar. So the simplified output expression will be written as F equals to C bar plus of A bar plus of B bar. So in this way, we can write the simplified Boolean expression from the available minterms by using the 3 variable K map. Now let's move to the 4 variable K map, how we can fill the cells of a 4 variable K map. Now in the case of 4 variables, so if we are having a 4 variables, so obviously that will give me a combination of 16. So I will be having 16 cells. That can be, I can manage it in the 4 cross 4. That means there will be a 4 row as well as there will be a 4 column. So let us try to visualize how we are going to fill the cells of a 4 variable K map. On this side it is AB and CD. We are taking a function of 4 variable as A, B, C and D. So the next thing is write the equivalent value 0, 0, 0, 1, then the last one 1, 0, then 1, 1. In this way 0, 0, 0, 1, last one 1, 0, then 1, 1. Now the next thing is write the decimal equivalent value. It will be 0, 1, 2, 3, 4, 5, 6, 7, and here it is a second last row. So instead of filling a second last row first, we have to first fill the last row. So it will be written as 8, 9, 10, 11, then the second last 12, 13, 14 and 15. So in this way we can fill the cells of a 4 variable K map. So the next thing is that it is not a hard fast rule that you have to write a AB on this side or a CD on this side. You can write a CD on this side also and a AB on the upward side. But the thing that you have to take care is, while filling the decimal equivalent value, you have to fill the manner in which you are writing the variables moving from a MSB to a LSB. So if suppose that I have written it in this way, like I am writing AB on upside and CD on downward. So how it will be written? This is your CD and this is your AB. 0, 0, 0, 1, 1, 0, 1, 1. Now while filling the decimal equivalent value, you have to be very careful about the manner in which you have written the variable. So it is AB on the upward and CD on the downward. So it will move like this. One is 0, this one will be 1, this one will be 2, 3, 4, 5, 6, 7. Because if you just observe the bit pattern, it will be 0, 0, 0, 0, then 0, 0, 0, 1, that which is 1, and then 0, 0, 1, 1, so which is 3. In this way you have to fill the decimal equivalent very carefully. The next thing is the second last column. So instead of filling a second last column first fill the last column. So it will be written as 8, 9, 10, 11, 12, 13, 14 and 15. So you can cross check your results. You can cross check whatever the decimal value that you have entered is correct or not. Just observe this case. This is the 15. So how in 15 in binary will be represented as? It is 1, 1, 1, 1. So it is a 4 bits, 4 ones. So just observe the row giving me a 1, 1, and then column. It is also giving me 1, 1. So whatever the decimal value that we have entered inside the K map, it's totally right. So the next thing is, suppose that if I am using just a random combination, suppose that we are having a 1, 1, 1, This is the combinations that is provided to us. Now we have to write the simplified form. So what is the combinations? What is the maximum pairing that you can form? Let's first observe whether we are getting an octet or not. If you are not getting an octet, then move to a quad. If not, then move to a pair. So if you observe that we are already getting a quad. Sorry, we are already getting a octet. So this is giving me a octet. Now the next combination that is left is your ones at the corner. So that can form a quad. This and this one. So in this way we will get the reduced expression of this as this octet going to give me a result of, in this row we cannot take anything common, but in this column, these two columns, we can take D as common. So D plus of, from the quad, the thing that we can take common is B bar, and then finally it is D bar. So these are the simplified result that you can get from this 4 variable K map. Now let's move to the next thing about your 5 variable K map. How we can draw the 5 variable K map. So we are having a 5 variable K map. So before drawing a 5 variable K map, let's observe about the pattern. We are having, suppose that 5 variable as A, B, C, D, E. So with this, it will move from similarly, it will go up to 0, 1, 1, 1, 1, and now it will change to 1. Again, this one will be moved to 1, and finally this will also move till the last combination. So if we observe, we are getting these combination for a value 0, and we are getting these combinations for a value 1. So that means in order to realize the 32 cells, we have to, or in order to realize the 5 variable K map, we have to take 2 maps or 2 K maps separately, and it will be of 4 cross 4. So let us see if you are taking a two K maps of 4 cross 4. Now the next thing is, this is for A equals to 0 and this is for A equals to 1. So it is BC and DE. Similarly, this one is also BC and this is DE. 0, 1, 1, 0, 1, 1, 0, 0, 0, 1. Finally, this cell. Now the next thing is that we have to write the decimal equivalent value. So if we are observing the pattern, we can see that this is 0, this is 1, 2, 3, this is 50. Now the next remaining combination, 16 combination, will move on this side. So it is 16, and this one. So in this way we have to fill each and every cell of a K map. Now we can take any variable as a 0 or 1. Instead of taking A as 0 or A as 1, we can take B as 0 and B as 1. The only thing, that point that you have to take care is, while filling the decimal equivalent value, you have to write the value as per the combinations that you have taken. So you can also reverse this order. Instead of a BC on this side, you can take BC on this side and DE on this side. In that case, the combination will move vertically. So in this, it will move from 0, 1, 2, 3, 4, 5, 6, 7, something like that. So you can verify for that case also. So I am leaving it up to you that even if we are taking, suppose that we are taking common, we are taking variable B as 0 and we are taking variable B as 1. In that case, what will be the combination that will be written here? It is A, C and DE. Similarly, on this side, it will be written as AC and DE. So while filling the decimal value, you have to be very careful about the combination. So while filling the values, you have to take the value as A, B, C, D, E in this way. In this way, you have to write the decimal values. So now, the very last thing is that, suppose that we are taking something min terms. I'm just taking a random values in this way, and this. So I have filled the cells in this way. So now in this, while filling the combinations, you have to treat each K-maps individually. So I will take both. Take both the K-maps individually and form the grouping. So the grouping that will be formed is, I have to be very careful while forming a group. So the thing that we can take common is, this is your octet, forming an octet grouping, and the next group that can be formed is your quad. The quad can be easily formed from these combinations, as well as if we are talking about this combination. So in this way also we are getting a octet, and then we are getting one quad. So while getting the simplified form of this quad and this quad, it will be written as, the thing that we can take common is your D bar and E bar. But I am not writing A is equal to 0 and A equals to 1, because even though if you are taking the A is equal to 0 and A equal to 1 in both the simplified expression, that will be reduced down to a 1 value. So you can just neglect A is equal to 0 and A equals to 1 only in the case where you are getting a combination at the same place in both the K maps. Like in this side, we are getting a octet in this K map also, at the same position we are getting octet in this K map also. So that's why we have neglected A is equal to 0 and A equals to 1. Now what about this quad? It is giving me a result of A bar, B bar, C, and similarly this quad is giving me a result of A, C and then D bar. So in this way, by combining this plus of this and this, we will get the reduced form of the expressions. So this is all about the K map till 5 variables. So in our next module, we will see what is the complex topic that we can take common from what we can take in the case of unit 2, and we will see in our next module of a lecture series. So thank you all.